Hi Chem Peeps, this is the third video in my series on electron configurations, and this is the shorthand method. This is the shortcut. In this video 2 I did hafnium, which was a very long electron configuration, and there is a way to shorten it. So above here on my slide I have steps that explain how to do a shorthand method, okay? And we'll do a couple examples together. The first thing you need to do is find your element. And so I had done zinc in the very first video, which is found right here, okay? And it wasn't too long, but it had 30 electrons, all right? What you first must do is go back to its previous noble gas. Column 18 on the periodic table are our noble gases, and they're used because they're pretty special. The noble gases have a complete octet. They do not have a need to bond because they have a full octet in their outer energy level, which makes them very, very stable. So we're going to use them as part of our shorthand method. So zinc is element 30. If we go back, argon with 18 electrons is going to be the previous noble gas. I am going to represent those 18 electrons that are found in zinc's 30 with just the notation of AR in brackets. Okay, so I'm just going to write this. You don't have to, but there's 18 electrons there. What I must do is pick up the electron configuration where argon leaves off. Except for helium, all of these noble gases land on a P6. And in fact, if we go back, argon is in row 3, so it lands on a 3p6. So I'm going to pick up the diagonal rule after 3p6 because all 18 electrons in argon are represented by its symbol. So after 3p, we come to the fourth row. The first thing that we're going to fill is the S cloud. So I'm going to fill 4s2. And then the next thing I'm going to fill is the D cloud here, but the D cloud is one behind the row. So even this, though this is 4th row, this is the 3D. And we saw in the video that I did that indeed it fills 3D10. And so when I add the 18 plus the 2 plus the 10, I'm going to get those 30 electrons. Let's try another example. We had done hafnium in one of my videos, the last one, and it was really long. So let's find where hafnium's at. It's found right here. It's in, we saw that it is in the 5D2 column. So everything in this whole column here, it lands on a D2, depending on its row. So hafnium is found in row 6. That is the 5D2. But I need to find the previous noble gas. So if I go back a row, the previous noble gas is xenon. Xenon has how many electrons? Well, it has 50, I can't read my periodic table. It has 54 electrons. And I'm going to represent my shorthand with that xenon in brackets. Now, remember what the rule says. It lands on a P6. It's in the 5th row there. So this is 5p6. So I need to pick up the diagonal rule here in the 6th row. And so I'm going to first fill this section, which is the 6s2. Then I'm going to come down here to the 4f, and I'm going to fill all of the 4f with 14 electrons. And then I'm going to come back and fill these two, which are in the D cloud, and it's going to be 5D2. And so if I add these up, along with the 54, I'm going to get hafnium 72 electrons. Let's look at some more examples here that I have. I just need to make my screen a little bit smaller so we can see it. In this example, I'm just going to move it over top of this. Here's the zinc that we talked about in the first video. Here's the whole electron configuration. I'm going to shorten it by representing 18 electrons by argon. So here's the shorthand. Calcium is found right here. It has 20 electrons. If I go back to the previous noble gas, it's going to be argon. So I'm going to represent 18 of the electrons as Ar. Then I'm going to pick up after argon in the 4s2. And so argon had 18 plus 2 is going to give me the 20. Let's look at the next one. It's pretty long. This is francium. Francium is found right there. Okay, we know that's the 7th row, the S1. Okay, so you can see that's the last thing. If I go back to the previous noble gas, I'm going to get radon. And radon represents 86 electrons. So radon is symbolized by this. We're going to represent 86 electrons. I need 87. I pick up on the 7th row, so I'm going to have 7s1. And that's how we do shorthand. Follow my next videos where I talk about different examples using the electron configurations that may help you. You can find me on TikTok and YouTube at sChemChats.